Hi, welcome back to the History and Philosophy of Science. This is our fourth video, so we're gonna do a little bit of review of week 3 and a preview of week 4. So let's get to it. Of course, we looked here at Karl Popper's views on defining science, and we compared them with Thomas Kuhn's work that we'd done in the previous week, and then we tried to apply that to the question of economics and whether economics was a science. Not exactly in that order, of course, but I just wanted to bring out a couple of things. One is there's not, as many of you noted, as many of you pointed out, there's not a lot of overlap between Karl Popper, at least the sections of his essay that I had you read, and Thomas Kuhn's book, at least the chapters that I had you read. Now, Popper does go into, he starts to kind of get into more overlap with Kuhn in other parts of his writings. If you read the rest of the Conjectures and Refutations essay, you might have seen more overlap there. But I did want to point out that the one major overlap which a lot of you caught on to was this idea of anomalies, that Kuhn's concept of the anomaly that ends up leading to the paradigm shift, to the change in theory, could be equated with Popper's idea of the falsification. Okay, basically, say you have a theory, say it's the phlogiston theory, and you say, okay, according to the phlogiston theory, I would expect, there's my specific prediction, that when things are burned, their mass would go down. Then I burn a metal, for example, like iron, magnesium, and I find out that the mass goes up. All right, now what do I do at that point? That's the question that Popper would ask. And interestingly, that's also a question that Kuhn asks. So that's where they're overlapping, okay? And they're talking, I think, really about the same thing at that point. And they really kind of seem to have the same ideas about it, the same opinion. That at that point, either in Popper's view, he would say at that point it's appropriate to trash the older theory. And what Kuhn would say is it's really not about what's appropriate or what we should or shouldn't do. It's just what happens, that some newcomer comes along and trashes the old theory when he sees the anomaly, because he doesn't have this kind of vested interest in explaining away the anomalies. All right. Now, an area where I'm not sure that they agree, and many of you pointed this out as well, is the idea of the changes in worldviews. Of course, Popper doesn't even really talk about that. He does kind of mention that sort of idea in the context of pseudoscience, but he does seem to have a more linear idea of scientific progress. At least he certainly doesn't make use of the Kuhnian view, which is that science isn't necessarily progressing, but just changing worldviews. All right. But I did want to mention again, and some of you brought this up in your essays, that we shouldn't necessarily think that Kuhnian's view implies no progress of any sort. There could be a kind of progress where each new theory is getting better at solving possibly a broader range of problems or just a different set of problems. You know, for example, with quantum theory, we might now be able to solve more computing problems than we had been able to solve in the past. And it kind of, makes you wonder if that blurs the distinction that I made last time between science and technology. I think I made that last time. And kind of makes you wonder, if we look at it that way, if we see this progress in technology, what if we did this? What if we viewed science as a form of technology, a problem-solving tool, and that technology was evolving also? I don't know, just something to think about. Kind of weird, but one of you, I was reading, I think, Justin's paper, and it was kind of getting into that question. All right, I just want to clarify one thing from the forums. The forum is really cool. I graded it fairly easily this time. I didn't. I cut you some slack in terms of some of the details, but in general, there wasn't really a need for me to cut any slack because you guys did a great job. I enjoyed seeing you respond to each other. You did a fantastic job in being very positive, and that was really unprompted by me. So thank you for that. That's awesome. I did want to bring out one thing that a couple of you talked about limits and how Popper said that a scientific theory should limit things. And so that was one of the reasons that economics was not science. Now, I agree with that to a certain extent, but just keep in mind that what Popper was talking about in terms of limits is that a scientific theory should be very specific. And so it should place definite limits on things that we would expect to find in the world. If it doesn't, then it can't be falsified. So when we apply that to economics, what we should be asking is this economic theory, for example, Marxism, does it put specific limits on expected observations such that we could, in theory, look out there in the world and see that Marxism is wrong? Okay, so just keep that in mind, that that's what Popper, I think, is talking about with limits. He's not talking about the idea that the government, for example, might impose limits on the economy. You know, like the Soviet Union, for example, making it so that you couldn't import any goods into the country, or at least severely limited things that could be imported into the country. You know, things like that are limits, but not really in Popper's sense that we're talking about. Okay, so that's just a little review of last time, and I hope that you still have some questions in your mind, because I certainly do, and these guys haven't answered all these questions. You know, I think Popper's got some really powerful things to say. And actually, I forgot I wanted to talk about induction. If you continued reading on in Popper's essay, he starts to get into the so-called problem of induction. And the problem of induction can kind of be summed up like this. There's no logical reason to assume, for example, let's say I'm out at just exploring nature, and I'm noticing that every swan that I see is white. Induction, in principle, would say that from that I will infer, or I could infer, that they're all going to be white. And basic idea would be the more swans I see that are white, the more confident I would be that they're all going to be white. And in fact, they would say, in applying this to science, you would say something like, if you see lots of swans and they're all white, then go ahead and infer that the rest of them are going to be white as well. And this is how we make general laws and theories from particular observations, from repeated observations. That's called the inductive method. It's known as the inductive method. Well, here's the problem with that. There's really no logical reason to assume that the next swan will be white, or that the next time I drop a rock that it will fall. There's no logical reason to assume that. Do you get that? That's the problem of induction. Now, David Hume, back in the 1700s, addressed this, and his solution was to say that that's true. There is no logical reason, and he might have been the first one to point that out. I'm not sure. It's not a logical argument to say that because stones have always fallen in the past, they will in the future. But we do have this intuitive belief. So his basic defense, or his solution, was to say, well, all right, but it's intuitive. It's kind of like a psychological habit that we get into. We just start believing that they're always going to fall. Now, that's okay, and I think that's fine, and we'll get into that a little bit more in a minute. But this leads to a problem for science, because science is supposed to be totally empirical and based on evidence and logic, right? Not on this kind of intuitive, subjective habit of mind sort of thing. So that causes a problem for science. Now, how does Popper deal with that? Actually, as I said, it's in the same essay on conjectures and refutations. If you're interested, just continue reading through section 3 till the end. Here's what he says, okay? So he says that induction is a myth, and the so-called inductive method of science is a myth, that it doesn't really happen. It doesn't work that way. Induction, let me clarify, is inferring general laws from repeated observations. Inferring general laws from repeated observations. So Popper says that's not really how science works. Rather, we start with guesses, or hypotheses, or conjectures, and we attempt refutation. All right? And that is how he sums it up. And when you do that, the problem of induction for science disappears, because laws simply become hypotheses, conjectures that are tentative. In other words, they just haven't been disproven yet. So what we do is we just say that in science, we're just tentatively holding to these ideas, and that solves the so-called problem of induction. All right, now I like that, and I think that's a powerful argument. I do think that it doesn't really, it's not really satisfying, and I think you'll probably agree with me on that. I mean, why is it that we all kind of believe that the rock is going to fall next time? Why is it that we don't even think about it, that rocks are going to fall? Why is it that we just believe that the next swan will be white? By the way, there are black swans occasionally. And there's another philosopher of science named Michael Polanyi, and I wasn't gonna try to get into this too much. I thought I had to draw the line somewhere in this course, but this book right here, Personal Knowledge Towards a Post-Critical Philosophy, another tremendously influential philosopher of science. In fact, a lot of what he says is very similar to what Kuhn says, and there's been kind of a debate in philosophical circles over where the ideas really came from, whether they were Polanyi or Kuhn. I tend to think that Polanyi was first in these ideas and went in much, much more depth. Interesting that Kuhn never mentions Polanyi that I'm aware of, at least in his book. Of course, he doesn't give a lot of references either. It's a very brief book. But let me just give you a rundown of Polanyi's views on science. He emphasizes its subjective element, that there's a lot of subjectivity in science, and there's a lot of intuitive stuff that goes on. Three areas in which he says this is true. First of all, scientists often use subjective criteria in accepting theories. Now, do you know what I mean by subjective? It's the opposite of objective. So subjective means it's something that comes from within me or within my mind rather than an outside object. And I think you'll see that science is supposed to be objective. It's not supposed to be based on opinion, value, judgments, that sort of thing. But he says that no, scientists routinely use subjective criteria in accepting or not accepting theories. They look for things like how elegant the theory is, how simple it is, preconceived ideas about, well, let me give you an example. This fits right in with what Kuhn was saying. Look at Claude Berthollet and how he hung on to his old idea that solutions were compounds, even in the face of Dalton's atomic theory, or the way that Priestley held on to his phlogiston theory, even in the face of evidence. They were using some type of subjective criteria in doing that. People accepted Einstein's theories before there was any evidence to back them up very much. People often did this. They would, they often do this. That just something that's so beautiful, that theory is so beautiful, it must be true. Secondly, we rely on our subjective assessment of probabilities and patterns. Those of you who've had my chemistry class know that I harp on this all the time. This is the idea of uncertainty in measurement. No measurement is 100% certain, and no observation is 100% certain. And yet we rely on them all the time. In fact, and here's the challenge to Popper, falsification is uncertain. So, I mean, I don't know how many of you might have thought about that. So, let's say I'm taking a bunch of measurements and one of them doesn't fit with my theory. Does that falsify the theory? Or could that be just random noise, error? What if 2 don't fit with the theory? What if 3 don't fit with the theory? If you think about that, you almost end up in the same problem as the problem of induction. How certain are you? And how does that certainty come about? I would argue, as Polanyi would, and really because of Polanyi, it's because I read him that I believe this way, but I would argue that the idea of becoming certain about something is subjective. It comes from within ourselves, and it's intuitive. It's kind of instinctual, if you will. For the same reason that a dog can catch a frisbee after it practices, right? Or sometimes before it practices. It's the same idea of how we can use scientific theories and how we do use them. And again, contrary to Popper, we don't act as if theories are tentative, do we? If you like my Christmas mug, it's a great time for that. We don't act as if theories are tentative. We usually act as if they're pretty certain, at least when we use them. I mean, we use a lot of these theories in critical situations. I mean, when they're building airplanes, they're using physical theories. So we don't act as if they're tentative. Thirdly, he talks about the subjective nature of skills. A skill like riding a bike is something that's subjective. It's from within yourself. You can't really write an article on how to ride a bike and then somebody can read the article and they could just do it. It's something that happens in what we call, it's a form of what they call tacit knowledge. And science actually relies on that. Any of you who have been in chemistry know that there's a lot of skill involved in using the instruments. And those are things that are passed on really by hand from one scientist to another in the scientific community and then down through history. So those are issues that raise questions for Popper, and I think kind of point in the, at least for myself, that while he's got some useful ideas about, I think the idea of conjectures and refutations is a very powerful concept. If we're looking for a broader picture of science, I don't know, just personally I favor the Kuhnian type of more, it's kind of a more holistic view of that science is really a human endeavor, and it's really not as objective as we'd like to think a lot of times. All right, so that's enough for week 3. Week 4 is going to be, I think, really cool. We are going to look at the origin of science in a historical framework. And we're going to be asking the question of, why did science originate in Europe? And we're going to, that might seem kind of narrow to you, but let me kind of clarify. Look, up until like from the 15 to the 1700s, which is when what we call the quote scientific revolution occurred, up until that point, Europe, if anything, was behind places like China and the Middle East in terms of science and technology. Okay, they were behind, if anything. They were certainly not ahead. But something happened at that point, and if you remember the graphs you made at the beginning, that's when that exponential growth curve took off. And if you look at those discoveries from about 1500 on, they're for the most part occurring in Europe, at least up until the 1900s, of course. But why is that? Why did it happen in Europe? And I've got a couple of good resources that we're going to look at to explore this question. The first is an article that is published in an Indian journal of scientific research, and I thought that was cool because you're going to get a non-Western viewpoint on this. So I don't want to approach this from kind of an ethnocentric Western way, and that's why I picked that article. Also because it looks like the author does a great job of considering most of the ideas that I've seen put forward, most of the hypotheses I've seen put forward. And then secondly is a National Geographic movie that summarizes a great book. It's a documentary that's based on a great book by Jared Diamond called Guns, Germs, and Steel, in which Diamond gives up what I think was probably a pretty novel theory about why Europe pulled ahead over time. And it's based on geographical factors primarily, and so that's just a preview of that. I'm not going to give you any more details of that, and what we're going to do is, I really like the forum approach, so I want to stick with that. You're going to respond in the form of a forum, and I set up a new forum under week 4. This time I'm gonna grade a little bit more particularly on this, so make sure you take a look at the rubric when you're doing that, and have fun with this. Again, if you have any questions, let me know. If you have trouble finding the rubrics, anything like that, just send me an email, whatever. The other thing I'm doing on this is, if you would rather submit a video of yourself giving your response and your responses, you may do so. You can post those on YouTube. Just know that they will be public, because in this case we're putting them out there to other students to respond to and so forth. If you do a video, it's just going to be held to the same rules as the same criteria of grading as the essay form. Okay, good luck with that, and continue to enjoy your summer.